This lesson is over similarity and dilations, and the goal is to use similar figures to find missing measures. Similar polygons. These are polygons that have the same shape, but can be different size. We talked about this a little bit in the previous unit with triangles and similarity. Same shape, different size. A dilation is a transformation that either stretches or shrinks a figure. If any of you have ever been to the eye doctor, had your eyes dilated, if you know what happens, you get a drop in your eye and your pupils expand. They kind of blow up like a balloon almost. And that's called dilating. And so they're expanding the same way. Okay, they're being stretched out. And scale factor is the ratio of a side length after dilation to its length before the dilation. Okay, in other words, the amount the original side length is multiplied by to find the side length of the image. So excuse me there, I just got interrupted. Damien Poirier just walked in the room and disturbed the video, so now we're back online here. So we're going to dilate the following polygon if the scale factor, or k, equals 3. So as we've done with all other shapes and other lessons, we're going to identify the points of the original. In this case, we have a trapezoid we're working with. So point A is right here, negative 1, 1. I'm sorry, negative 1, negative 1, excuse me. Point B is right here, that's 0, 1. Point C is right there, that's 2, 2. And point D is right there, that's 3, 0. So now we multiply each coordinate by the scale factor. And what that means is each number within a point multiplies by, in this case, by 3. So A prime, I'm going to do this first before drawing it. Multiply each point in A by 3. So A prime is negative 3, negative 3. B prime will become 0, 3. C prime becomes 6, 6. And D prime becomes 9, 0. Again, multiplying each point by the scale factor. So A, we have negative 3, 3, so 1, 2, 3, 1, 2, 3, right there. Then B is 0, 3, right there. C is going to be 6, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then D is 9, 0. And without a ruler, which you guys always should use, but I'm not going to, I'm going to connect these points, which are pretty darn straight for not using a ruler. So there is our dilation. Next, we're going to go the other way. We're going to shrink the item. So the scale factor of this triangle is 1/2. So we're going to shrink it down. Start by naming our points. So point A, 1, 2, 3, 4, 5, 6. That's going to be negative 6, negative 4. And B is going to be at 1, 2, 3, 4, 5, 0, 6. And then C, sorry, I should mark the C as well. 1, 2, 3, 4, 1, 2, 3, 4. Is that 4, negative 4? Now, we're going to multiply each coordinate by 1/2. Make those our prime coordinates. So A prime, cut them each in half, becomes negative 3, negative 2. B prime becomes 0, 3. And C prime becomes 2, negative 2. Again, just multiply each point by 1/2 or divide it by 2. So A prime is negative 3, negative 2. B prime is 0, 3. And then C prime is 2, negative 2. And it looks like about half the size. That is our dilation lesson, folks. Enjoy.